Also, while you are all typing in the chat what pathway you're a part of, I'll go ahead and get some stuff out of the way before, so we can get this going. Respect everybody's time. But tonight we have an intuitive introduction to AI. The sentiment cluster topic analysis model. I had to click on the title for that because I forgot what all it was. It's a great title. Next week, we actually don't have any guest speakers, and the one after that, we also don't have any guest speakers. We pick back up on the 14th. It'll be yours truly and Danny Morton talking a little bit about what do you do after you graduate. So that should be a really interesting time, so please show up for that. If you want. In general, we're always looking to schedule more events. If there's something specific you sort of want to see, let us know and we'll try and find somebody to give that talk. In general, some of you have just joined, so I'll sort of mention this again. If you have questions, type them in the chat. Feel free to do that. You can also come off mute and just ask them. If Ofir asks a question, feel free to answer it by coming off chat or type in the chat, whatever you want to do. I'll be around, so if he misses anything, I'll be able to grab it. But without any other messing around, we are here with Ofir Klein. He is a data platform architect at Coastal, and so I'm just going to sort of hand the keys off to him.
Appreciate it, David. Yeah, thank you for inviting me. I appreciate, I always appreciate coming back to Code U. It's always a fun time. Let me just get this so that we're all seeing something nice together. Cool. So my name's Ofir. O like the letter, fear like the emotion. As David mentioned, I'm a data platform architect. That's just a fancy word for saying that I spend a lot of time in Lucid charts, spend a lot of time with clients, and working to provide solutions that just make sense. As I told everyone when they joined before this call, David was wearing such a lovely shirt that I thought I had to match it. I thought it looked a little bit too corporate with my work attire. So I decided to get a little duck and database shirt on that I had acquired of recent. So, keep things light and keep things fun. So today we'll talk about an intuitive introduction to AI, right? And when we say AI, I have very specific meanings about that. So I want to provide some clarity on what these terms are, because I'm sure you've heard many of them all over the internet every day on every platform you can imagine. So we'll go through that. I want to talk about a model I've created years ago, but I think it's a good way to kind of provide some confidence about what this field's about and what you can do with it. So we call it the sentiment cluster topic model. Wonderful. So like any good thing, we need an agenda. We, in order to know what we're doing, we need to know where we're going and where we have to go and all that fun stuff. So I'll talk about, I'm going to situate this in a problem. There's a little bit of a preface before we get started about how to kind of orient our mindset a little bit. I'll give some starting definitions. We'll jump into the first part, which is sequentially ordered, so the sentiment analysis. We'll move on to clustering and something called LDA, which is topic analysis. And then I'll put it all together in a diagram so you can see a little bit of what data architecture looks like. And then I'll talk about some of the results and findings and things that were interesting. Then hopefully there's some time for QA for you to ask me about this, some other things, whatever you want to talk about. So introductions. I'm not typically one who talks too much about himself. I find it to be a weird retrospective thing. That's a me problem more than anything else. But yes, as David said, I work for a company called Coastal. It's a Salesforce consultancy company, so I'm a consultant as well. They primarily focus on Salesforce implementation. If none of you know what that is, it's totally fine. You're not missing out on anything. But some of you, when you leave Code U and you enter the big bad workforce, may come across Salesforce, which is a CRM. I'll leave all of you to Google what that is for anyone who has questions, but less about that. So I'm a data architect there, and I just work with clients. I'm client facing, and I build a whole bunch of different kinds of solutions. So analytic solutions, operational solutions, and then for the special folks, I do a lot of the machine learning stuff in the house, which is the AI part. I used to be a programmer, a data analyst. I have no formal training. I have maybe one course I have ever taken in my life. To do this kind of stuff. I'm self-taught, and it's been kind of a really long journey to get to this point. I started out 7 years ago writing Python. I gave up about, and I'm not joking when I say this, 10 times because I found it absolutely infuriating that I could not grasp this thing that somehow people were using and could understand. I then found some friends, a community, and it kind of led me down a path of curiosity. I found some books. learned about which books were good, which weren't, which spoke to me, which didn't. And then eventually found, broke in, and started to become a data analyst, and then eventually software development, did a little consulting on the side, and then eventually way down the road, I ended up here, and that's kind of what brought me in today. So originally from New York, so the grind, the hustle, the bustle is where I'm originally from. I lived in Lexington, Kentucky. That's how I eventually started and met David at Code U. But now I live in good old Santa Fe, New Mexico. So it's 4 o'clock here and the sun is beaming. So today we're going to talk a little about machine learning, and I really want to focus on this. And that's primarily what I do at work. Not all of it, as we'll get to it. I'll explain why that is probably not the best use case for everyone. But let's focus a little bit on machine learning. But before I get started, anyone have any questions, concerns, wonders? Feel free to interrupt, please. Alrighty, so you've all heard AI. AI, right, is a acronym for artificial intelligence. It's been around since the 70s. We've been using this stuff well into the early 2000s, and then it kind of proliferated in the early 2010s with this idea of quote unquote big data. Big data doesn't really mean what it used to, but what it used to mean was that there was so much data, there were terabytes and terabytes and petabytes of data, and you needed new techniques that you couldn't solve in a single Python script or a single C# script or a single web application. There was just too much information, and it was too slow to process or acquire or retrieve any information. So what ends up happening is there's a whole proliferation of new techniques that have to be rethought and redefined that elaborated on the ones that had come out of the 70s and 80s. And that's kind of the era we're in right now, that eventually around 2017, 2018, 2019, that's when the large language models start coming around, which is a subdiscipline in machine learning. I'll get to a definition of machine learning in a second. And that's kind of the trajectory, right, of what we're in now. We're now used to the GPTs, the Geminis, the LLMs, all that fun stuff. But what we're going to focus on is what they're comprised of, because all of those large language models can essentially be broken out into this chart, and it's non-extensive, right? So it shows a few techniques and a few things, but this chart can encapsulate easily what LLMs do under the hood or have been trained to do. So machine learning is nothing more than a discipline, right? It's a discipline from the academics in computer science, and that's where it gets its name from a paper by a gentleman named Arthur Samuel, who did checkers. He figured out the program for checkers so that you can have a computer play against itself so that it could get really good and beat humans, right? And that's that whole era. If any of you are really interested in Deep Blue, that beat some of the grand chess masters. This is part of that era in the 80s and 90s. So machine learning is really just about this. You have some data, you have a program, right, like a function. You feed the data into the program, it returns new data, and then that starts again at the new place that you saved your variable or your data, right? So it's just crunching some numbers, returning it to a storage unit, right, or a variable, and then reprocessing it. And then you can make a prediction, or you can make an assessment, or you can make an action item from that. That's all that this stuff really is, right? It's just a for loop that runs, that keeps running against some stored data somewhere. And then what you get as an output is something to help you identify something, predict something, forecast something. Recursion is part of the original techniques that primarily use this, but not every system's optimized for it. But that's okay. But yes, that is what machine learning is, right? It's just a series of techniques that you know, built on the primitives of what you've learned here, that uses some techniques and some knowledge from statistics and whatnot, including some best practices from software engineering and this and that and here and there. And that's what all these are for. So you can kind of break down machine learning, which is just this thing to predict stuff or get outputs from it, right, based on your data, into 3 major subdisciplines, which is unsupervised learning, supervised learning, and reinforcement learning. Supervised learning is what you're going to learn in stats, right? That's your regressions, if any of you have heard of them, right? So forecasting, or hey, I'm living in X area and I want to predict the market on house prices for when to invest or get a house. Give me the lowest one. That's the supervised learning, right? Where you get a whole bunch of data, you basically train it, right? You make it run on a specific set of it, and then you have some data that you say, hey, now that you've learned something from this, try it on that and give me some answers. That's it. Unsupervised learning is a lot of what's happening today, and it's a really good and interesting field where you don't have anything, you just have the data, prepare it, and then you throw it inside of the program, or what is sometimes called in the industry algorithms, and then it pumps out something. So we'll be going over 3 today that we just have inputs and outputs, and you just need to have a conceptual understanding of what's going on. And reinforcement learning for any of the folks is a lot of what your gaming systems are based off of, right? So how your NPCs or how your enemies are getting better on hard, easy, or medium, right? How they're doing advanced tactics to kind of beat you. Robotics is part of this. A lot of reinforcement. It's a really interesting field. It's a little bit complicated, so we're not going to touch too much. But the main one I want to go over is unsupervised learning, which is you have a program, you have data, you prepare the data in such a way that you can feed it into it, and it pumps out something. And I want to just focus a little bit about the intuition, which is reading from left to right. Your left is how you're going to build these things, right? So that's the imperative steps of, okay, I need to create a variable, I need to do a loop, I need to have an algorithm that runs this kind of statistical analysis or this kind of, predictive analysis. That's great, but the more in the weeds we get there, the less we're going to keep the big picture. And as a consultant, I'm going to force us a little bit to think about what is the ask, what's the need, what's the problem, and think about it big picture first is what is the things we need to do to get the data we need and in the right shape to perform some action, some business use, whatever. So I want to focus on the right side, which is the what, right? What are we solving? What is the problem? When is it the right use case? That's it. So we're going to work on that intuition a little bit. And before we do that, I just want to kind of preface is not everything is this kind of problem, right? Not everything needs to be thrown at a machine learning model or AI or whatever you want to call it. Please, that is not the case, right? So there's a really lovely book called Deciphering Data Architectures, which talks about kind of the new age of these larger enterprise level platforms that emerged out of like SQL and Python and all these kinds of really interesting things. But they have this really beautiful diagram that I like that kind of talks through, data maturity. And the first step is if you're throwing around Excel spreadsheets, this is probably not for you. If your company has a SQL database and some Python stuff, and you're just trying to get organized because you're starting to get, bigger, you're on stage 2. That's fine. That's probably not what you need. The 3 and 4 is where this becomes actually more important. So the 3 is really just now that we have the infrastructure, we have some databases, we have some what we call pipelines or integrations, or your Python is speaking to a REST API or a SOAP API, and it's retrieving information from some source. So you have 2 things speaking back to one, back and forward. Now that everything's kind of in place, and the data is streaming in, now we can predict something, right? Because it's structured in a way that makes sense, that's organized, and just in a centralized location, so we can get started. Fantastic. That's where this becomes important. Transformative is your Google, your Facebook, your Meta, whatever you want to call these companies. That's when they're self-sufficient, when they have their own extremely large organization, there are multiple databases, there are multiple, they call them sometimes markets or teams or divisions, right? They have their own analytics people, right? They have just their own business internally is like a cluster of separate businesses that are self-sufficient. So the machine learning stuff is really around maybe at best in between 2 and 3, but it's really 3 and 4. So I just want to kind of get everyone, right? Like when you're talking or you're thinking about a company or people are talking about that we need to do this kind of stuff, really gauge first, like where are you in maturity? Do we need to focus on ramping up the infrastructure, or are you already there? So not everything's a machine learning problem. Not everything can be solved by AI. I've met plenty of people on plenty of calls that think that they're really ready. And then when you ask them questions about their data, they're not ready. So just always keep that in mind. So now that that's settled, I think we can get started about this intuition and machine learning and this unsupervised stuff with a problem. So I don't really like the word problem. I think situation, right? You get into a circumstance. You're thrown into work. You're thrown into a day. You're thrown into a meeting, and suddenly someone's asking for something. So let's think back a little bit to the early 2010s or mid 2010s before ChatGPT, right? We can call those the olden days, so to speak. So you work for a company called Data Center, right? And they just got this new product out on the market and starting to really catch fire. How do we know that? Well, you're not having so many reviews yet, but you're seeing a whole bunch of things on Twitter. Yes, Twitter, before we called it X. And that's where a lot of people are starting to posit their insights, likes, dislikes, reviews, sharing a whole bunch of stuff about your new data product. So your boss comes up to you one day and your team and says, hey, look, I want to take, somehow I see that we're not really getting so many reviews through our own forms, but I see on Twitter we're trending and there's a whole bunch of stuff for the last week. Is there any way that we can turn this collection of stuff into some kind of insight? Right? And that's becoming the question of how do we make it actionable? Right? How do we take the insight that we get from this collection of tweets and better inform our product? How do we make it better? What critiques are there? Those sorts of things. So here's the first question, right? How do you break down this problem, right? What are some obvious things that maybe are interesting to start considering? This is where I don't mind sitting awkwardly as I drink water, as you all, until someone answers. And there's no wrong answers, and if there's a simple one or a straightforward one, take it. I hear someone.
Oh, step by step. I pressed the wrong button. I was trying to type.
That's okay. So define your data is one, certainly, but how do you define it? Define it in what way? Jim, you're muted, just letting you know in case you were speaking. So to just get the ball rolling, as Jim is typing, right? Well, if we have a product, don't we want to know what people like about it? Right? Like what's good and what's bad is certainly one way to define your data. How do we figure out what is good data from what is bad data? That's one way of asking it. Oops.
Would that be feedback or like?
Yeah, absolutely. So positive and negative feedback. That's absolutely right. So we're dealing with people and their reactions. Great. So the data is in text form. We're not dealing with numbers. We're not dealing with floating point decimals. We're not dealing with Booleans, true or false, right? We're dealing with people's natural language, right? We're dealing with good and bad. What else can we maybe think about our data? So one person might have a good response and one person might have a bad response. How do we scale that up or ask about not one, but many? What's a question we could possibly pose? And again, feel free to type in the chat if you don't feel comfortable. And there's no wrong answers. This is just a matter of perspective, right? You'll get thrown into this at work. I get thrown into this pretty much every day. Hey, someone's dealing with this. We need to ask questions about something.
Would it be something like if you could change one thing, what would it be? Or basically, what is a feature or function that you would like added?
Sure.
Something.
But take that one step further. So one person said that. How do you know that one person is significant, right? Like every customer is significant, but how do we know that there's a trend? What do we have to look at in our data to find a trend?
Basically kind of repetition, like it's been mentioned like multiple times, and then that's where you know the problematic area to kind of focus on.
Yeah, right. So the idea is we're not dealing with one person, but we're dealing with a group. So not only do we want to know good and bad of what people are thinking, or in one individual, one at a time, we want to know if there's a group of people who think something's positive or negative, and perhaps if there's a group of people saying we want this feature, right? So we're thinking not only about individuals, but groups. So we have to scale it up, right? So we think about not one, but many. And just the last one to also consider is, are there bigger themes going on, right? So not just that, hey, look, this is positive or we want this feature, but maybe there's a nuance. Maybe there's a collection of themes happening in those discussions. So one of the first things you want to do in these kinds of things is figure out some questions, which is, right, We know that we're dealing with natural language, right? Because we're not dealing with numbers, integers, or bools, or any of those kinds of data types, right? We're dealing with responses, right? Good, bad. We're dealing with groups of people, not just individuals. And also we're thinking about bigger themes, right? Because maybe it's not so apparent that everyone's talking about a feature, but maybe they're talking about, I like this is a little bit awkward, right? So there's something neutral and something not specifically asked for, but something that we have to as people, right? When we hear people talk about and respond towards something, we take that as feedback to derive larger themes. And then there's always data cleanup. So in the world of machine learning, right, about the what are we trying to solve in each question is a little bit easier to do, because we need to figure out what kinds of techniques do we need to implement. And in this field, it's always really helpful, just like as you're learning through your courses, right? Like there's different data structures, different techniques, loops, recursion, all these different kinds of web frameworks or, libraries that facilitate you to answer or do certain kinds of transformations to respond to certain kinds of questions. So certainly we need to know what we're dealing with. And so the language here is natural language processing, which is called NLP, which is a subdivision of what those LLMs use, right? It's in the same discipline, so to speak. Well, we know we're dealing with good and bad in colloquial language is called sentiment, right? Good, bad, neutral. And so there's something called sentiment analysis. So now we're learning something more about machine learning, about the techniques and the discipline of it. Well, we also know that we're going to have groupings, so maybe we need to cluster them together to figure out who belongs in what camp, so to speak, the good, the bad, the ugly. So we call it cluster analysis. Notice how all of these are unsupervised learning techniques. And then the last was we want to extrapolate, right? Extrapolation is the key term, larger themes. So suddenly we have something called topic analysis. Now all of you are armed, you know the discipline, and you know 3 techniques in this thing that you can go home, or well, you're all home, so now you can Google and look up and be interested in. And this is kind of the Venn diagram, right? And the top left is the biggest one. You will spend 80 to 90% of your work there. I promise you. You cleaning the data is a iterative process. It will take most of your time, but when you put these techniques together, that's what today's about. So let's start with some definitions, because it's really inappropriate to talk about things if we don't all have the same understanding of what it is. So in order, right? Sentiment, cluster, and topic analysis. Sentiment's intuitive, good, bad, neutral, right? That's what we want to know. We want to know how people derive their sentiment towards something. There, in the middle, we have a cluster analysis, which I always like this image, right? So you have all your data mixed up, and then it just puts it into buckets that you tell it to, right? So 5 buckets, I have this data, put it inside, and that's what we're going to look at. And topic analysis is, right, that nuance where you can have a whole discussion with a friend going through a series of conversations. And then if someone was listening, it's like, what were the major themes talked about, or what were the major topic points? Gossip, heat wave, sports, and food. These are all things that we do intuitively and that we know. We just need to formalize the language just a little bit. So let's just jump right into sentiment and get started. And again, feel free to stop me at any point. So textbook definition, it's a technique used to determine the emotional tone behind a piece of text. So positive, negative, and neutral. So I don't like to come with just showing data points. I actually want to show you, like, what does this look like? So take 30 seconds to just read these 3 tweets. And if someone would have courage, just tell me positive, negative, neutral. And then the following question is going to be, how did you know? So nothing crazy, nothing you don't experience every single day. So positive, negative, or neutral? Yep.
I think positive is the first one. Just got my hands, and wow, it is a game changer. That's positive.
Mm-hmm.
Neutral is the second one. Anyone tries, someone is like doubting, and no, that's neutral. And negative is the big regret buying the
Stunning, right? There's nothing tricky about that, right? And I'm gonna pick on you, Osvaldo, if that's okay, just for a little longer, just
Sure.
for fun. So you've done beautifully, right? Like you've read these and you've deciphered it somehow. Can you tell me a quick example in each one of these, how you figured it out? I know that seems simple, but just walk through it with me, just for fun.
I figured out just looking for keywords.
Okay,
Like,
keywords.
wow, game changer. In the second one is like is doubting about it. Is so not sure. Anyone has solid review, and the negative one is the big regret. Just looking for keywords.
Got it. Hold on to that. Charles, well, how did you?
Yeah, basically, I'm kind of in agreement, but the first one is positive. The last one is negative. I did not get neutral based on your sentiment analysis description from the second one. The middle one is more fact-finding because he's saying some people are saying it's amazing, others are saying it's bad, but I'm not sure if I should do it or not. And according to yours, neutral is good job, it needs improvement. And that is asking for an analysis or a review, which the middle one is not giving.
And again, right, that's the whole point of how challenging this can be sometimes, which is two people can read something differently, but then the computer has to read this, which it has no notion and understanding, right? These are all text fields. So suddenly, and somehow and in some way, we have to derive a tone. So I like what you're both putting forward. Let me add to both what you're saying, right? Some ways that you can also know are through emojis and capitalization, right? Not just the keywords, but using a whole series of punctuation can help, right? The 4 exclamation points at the bottom, right? If it's a positive, can inflect higher positivity. So there's a scale. And right in this bottom one, it really inflects a lower negativity. So what I want to kind of show you all, so thank you, Osvaldo and Charles, is when you read these, based on what you're trying to define, that's kind of the most important criteria. We can look at words as keywords. We can look at emojis. We can even look at phrases and punctuation and use those to help us kind of rank in our heads what these things mean and what sentiment to give them based on how positive they are, how neutral they are, and how negative they are. And I want you to keep that in mind because really human language is about rules, right? And rules and conventions change over time. And that's how this was actually derived. So I want to introduce you all to something called Vader. I wish I gave this presentation last month on the 4th. It would have been a little bit more humorous to be talking about this. But Vader is just that. It was a multi-method approach to scoring. And what that means is that they had humans read tweets, very technically what is called a micro blog in a technical form. And those just last, 250 characters or something. And this is what this analysis is specifically built for. And they would grade them, positive, negative, neutral from a score of 0 to 1. And they did this so much that they wrote an algorithm from scratch that would take the results, use it, and then get trained on it. And what ended up happening, as this paper introduces and what they've improved on, is that it outperformed the people who trained it to such an extent that it got the nuances in between, and all you had to do was kind of improve that rule-based approach. So just like we were sorting out and identifying keywords or phrases or emojis, it does all of that. And that's what it's built for. And that's all that Vader does. It's just a rule-based algorithm that pumps out a number, positive, negative, and neutral scores. And so I don't like to just say things and hope you get it. This is what it looks like, right? There's your overall sentiment dictionary. So there's your data structure, a hash map if you're in C# or an object if you're in JavaScript, right? So here's your negative score, your neutral score, your positive score, and a compound to normalize them. For any of you who don't know what normalization is, that's totally fine. I'm not going to touch on it. But I really just want you to see that, look, these are out of 1, and you can see this is exceptionally neutral, right? And then here it kind of blends. Here it's more neutral than anything else, right? And so this is how it pumps out information. So if we were to if we were to just showcase this as a chart, right, as a data frame, or for many of you who do like Pandas and the data analytics route, right, Pandas data frame for people in C#, this is just a hash map that has a bunch of arrays or lists if you're in Python. Right, all you're seeing here is more or less an Excel spreadsheet that can be virtualized in a programming language. But look, here's your tweet, here's your data, here's its ranking, and then right, that's all. You're done. This is how this algorithm works. You understand. We just work through it. Right? There's nothing more that you need to understand on the what. So I really like this idea of thinking about we're turning text data into data points. And when you turn text into numbers, right, when you change the data type, something very powerful happens. What happens is that now you can start to think in a different way about your information and what you can manipulate and do, and it opens up new techniques. And to just spoil the fun, right, this can be thought of as nothing more than an x-axis and a y-axis. So you have your text data, which is in the terminology, it's called unstructured data, right? It's just a bunch of text. And suddenly we give it a numerical scoring, and then suddenly we can do things with that numerical scoring. And what I want to propose is that if you do X's and Y's and you say, hey, look, based on these two columns, compare them against all the rest and show me what could be positive, negative, or neutral in groupings, then you can get something like this. Now, this data is very messy, and I left it here for a very specific reason, but this is the idea that you can, by changing your data type from taking text and turning it into data points, it opens up fields of what you can do. Now, what you can think here in these tweets is someone who sent the word nice with an exclamation point, or sucks, right, which doesn't have any other context, which is based on its own scoring. It has nothing to do, so that's where you get these ranges. But you can filter them out, and then suddenly you've cleaned your data more so. There's bots also, right? We can't forget about those things on things like X or Twitter, which need to be filtered out, which there's other ways to clean your data. There's other ways to get better scores by something called scrubbing or cleaning your data, but I'm not going to go too much into that. But I just want you to see that suddenly we just had a program. It was called Sentiment Vader Analysis. We put in right, the text data, it pumped out scores, I saved that somewhere, and then suddenly I can make a visualization. It's really that simple. Yep, Lucy.
Can you go back one slide previously?
It would make me happy to, yes.
I'm just glancing at the words positive and negative. So the more negative Vader score is a more positive tweet?
So good question on how to read this. So a tweet, so any one of these circles is a tweet. So this one says that based on how to look at it here is that its negative score, it has a negative and positive. So if we looked positive as 90 and had negative of 5, right, it's probably this one. Because you read it from your y-axis to your x-axis, right? Or probably, you know, the fake, I made it, it was a fake one, but you can start to see that, right, this would be around 9, and its negative score would be like 0.1 or something. And that's how this is to be read, right? You're just taking those two axes and you're putting them and you're slapping them together, and suddenly you can get a visualization of these data points are far more positive. These data points are far more neutral. Maybe there's some nuance along in there. Does that work for you, Lucy?
Yep. Thank you.
My pleasure. Charles.
Is the color legend backwards?
It's non-discriminatory at this moment.
Well, you
yes,
have negative
yes,
as red, and you have positive as green.
Yep. Good
and
cat.
then you have all the green on the negative Vader score, and you have all the red on the positive.
Yeah, that might have been my mistake in doing the
Okay,
labels.
okay. No, that's just totally fine. I was just kind of confused about that.
See, in this
But I
world,
understand what you're saying.
Yeah.
It's just the visualization seemed to be backwards to me.
Yep.
So that's all.
Again,
Thank you.
for everyone, this is why I bring it to such world-class folks learning, right? Because you see the things that need to be seen. But yes, so the colors are off. It should have been switched, which is just a silly mistake on my behalf, but the point still rises, right? Don't ignore the color. It really doesn't matter as much, but here's your negative and here's your positive. Beautiful. David, I didn't know you had such crazy sharp people around. I would have, come up with some more things for them to poke holes in.
Yeah, they're great. Yeah, they're really excellent.
So let's talk about clustering and topic analysis, just to kind of get things along. So we just saw what a cluster analysis looks like. You get the 2 columns that you need, and it runs through it, and somehow and in some way it pumps out groupings, right? Or it's called K-mean. This one is called K-means cluster. All that means is the K stands for how many bins you want. And if you imagine like a little kid going to having taken their toys and put it on the ground, and then suddenly their parent comes to them and says, hey, if you want dinner, you need to put these away. They start to take their toys and start putting it in buckets, right? And they know maybe they only have 3 buckets or 5 buckets or 6 buckets. So they have to think about, if it's a very smart child and very intuitive, it depends what age, they'll start putting it like dinosaurs together, Legos together, or maybe colors together, right? Kind of whatever they're going for. And that's all that K-means does. And if you're interested, jump more into it. It's not a crazy algorithm to get going. It's very easy on Python or any of these languages. It's not anything too difficult. So I recommend it. The next one's a little bit more intensive. It's based on statistics, but the idea is really simple. You have a text and there's some major themes, and you want to know what those themes are. What it does is it goes in and it starts to look at the context, right? How words relate to one another along with synonyms. So it has some dictionary stuff built in, some natural language stuff built in. But what it does is it pumps out topics, right? Genes, DNA, genetics, life, evolve, organism, brain, neuron, nerve, right? And then as the user of said algorithm or user of said program, it's left for you to interpret what those are. So, right, you need to know the data, you need to be kind of speaking to it and have it speak back to you. And this is called the LDA, right? So it's a kind of topic analysis. If anyone's interested, right, like jump in more. There's a whole bunch of them, but for this specific one, it's suitable enough. So if you put these together, right, if I show you what an actual clean cluster looks like without any mistakes, this is what it looks like. So you can see that on the left side, we have 6 bins, right, or 6 Ks. On the right side, we have 10. And all that this is showing is the level of granularity, right? So this is your negative score, your positive score, and these are, if you wanted to jump inside, you would think of a 3rd column in Excel that would give a number between 0 to 5, and you would filter on that. And then suddenly you have all of your data points that you can then investigate the negativity, the positivity, the neutrality of them. And it doesn't really stop there, right? So for these data points, which is quite a many, as you see, they're all scrambled together, you can get even more granular. What's even more fun is you can redo this analysis on any one of those and get more fine-grained results as to what those things are. So this is what it looks like as a K-means or as a clustering. And here's what the topic analysis looks like, right? So this is when Bitcoin was really big, and there was and you could still get all the free data from Twitter. But so this was mined, I forget which specific library in Python, but I think it's like SK Twitter or something. It used to be the big one. But here's the clusters, right? So there's cluster 5, 1, and 2. And suddenly we can read things like Bitcoin, time, China, market, dollar, great, thanks, opportunity, need, coin, price, last, hour, Bitcoin, stop. And suddenly we have topics, right? We have things that people are discussing in those groupings, in those clusters, and we can get maybe some insight from them. But did anyone notice an issue? And I promise it's not in the formatting, right? I've double and triple checked this one. Anyone notice a strange issue if you just do a topic analysis on its own? Because again, I'm taking these as independent.
You don't know the sentiment, but I
There
can
you
still learn
go.
the sentiment.
Absolutely. Because I can read it as great, thanks, opportunity, need, coin, or great, thanks, opportunity, need, coin, right? That is the whole, and people do analysis and use this technique and don't know how to decipher it because the data has no understanding, right? The algorithms have no understanding of the context. That's why LLMs got really big, right? Because there are techniques and architectures and programs to actually understand the context of how things relate to one another. This was before that. There was none, right? There were techniques, but I didn't use them here. But after you read topic 2 in cluster 1, there is no definitive way outside of looking at the data for you to understand and infer that this is positive or negative. So then, how do you know if this cluster is saying something about your product that's good or bad? You don't. Then suddenly, you just wasted a whole bunch of resources and time. So the architecture is meant to supplement those problems, right? You have sentiment, but you don't know how to scale it up to a grouping. That's where you get the cluster analysis, right? You can get topics and themes, but you don't know, right? The computer has no idea about the context of, is it positive? Are those meant to go together? What groupings are they? Right? So this whole thing is meant to solve sequentially 3 different problems. And if you place them in that order, it responds to many questions that you can have and get answered. So here's what an actual data workflow would look like. You get your CSVs, here's your Python, right? All in the beautiful white. You dump it into your source tables, right? Or your Excel or your data frame or whatever. Then you start to go through this process called feature selection, data scrubbing or cleaning, and then get your filter criteria on what you need. So in this, it's remove bots, right? Figure out an algorithm to displace them. Get rid of words you don't need for processing, like in, a, the, about, stuff like that. Prepositions, sometimes articles, indefinite or definite. And then your filter criteria, right? Like, now that I have these and I've scrubbed them, or maybe I want to take a verb and make it, I am eating. Maybe I just want to do eats. So then that way we have better understanding, so the computer can better analyze these things and understand their relations. You then get your clean data set, which is in the middle. Then you just dump it into that sequence of Vader, iteratively look over the scores and see if it makes sense. Well, how do you know? Visualize it. K-means cluster. Throw it on a graph. Oh no, we saw those weird lines that were all on the edges. We forgot to take out those scores that were pure positive, pure negative, and only had a length of 1 character, right? Good, bad. So this helps us iteratively go back and refine our model, right? Refine our process. And then once we feel good, we dump it into the topics, and then suddenly we can actually go into that cluster, into that group, and start seeing, what do they mean by these topics? What do they mean by Bitcoin, good, money, this, that, right? So all of this is an iterative process. You constantly have to be going through it. This is, I think, one of the damaging things sometimes is we got used to just throwing it at a GPT or at a Google, and we didn't think about the criteria of how to actually use it to our advantage. So when I just try to think about models, I think about, right, how to keep the human in the loop, right? How do we keep ourselves, even if we don't know the underlying mechanics of how it's grading or organizing or classifying, we can derive an understanding conceptually and then say, hey, look, this is the problem in our data, right? Because the expression is data in, data out, right? Trash data goes in, trash data comes out. Clean data goes in, good data comes out. So it's an iterative process that requires conceptual understanding of what you're trying to solve, but also an intimacy with your data as to what it's trying to express to you. Once you're done and feel good, you have your final data set. Great, now you can go action on that. Maybe you can go visualize it. Maybe you can give it to business owners or executives. Maybe you can provide it to whomever. And then suddenly, it's not just that it pumped out a number or predicted something, but now you can actually work with people, and it's not a technical problem anymore, it's a people problem. And then organize them in such a way that they can now make your feature with the exact things that it ought to have, not just what you're guessing at, right? Or redesign your platform, or redesign your logo, or move a button, or this or that, right? This is how you then, the world doesn't need to pump out a number to tell you what to do. You can have it, and it informs your insight to make actions. So when you put it all together, this is what it looks like, right? Nothing crazy, nothing too outside of your reach. And really, what does it look like under the hood? This is what it looks like, right? It's just a series of tables and columns that you can visualize in your head, or you have stored somewhere, that has your positive scores, your negative scores, your k-means cluster, where those things are located, and then here's your topics in those that end up becoming the big picture ones, but you can change it and redefine it in certain specific ways. And you can do more analysis. You can do more things on this. It's not just limited. And the architecture is, suppose this didn't work, that maybe you're not dealing with a microblog like Twitter, maybe you're dealing with pages of a book, or maybe you're dealing with manuals, or maybe you're dealing with this or that or another. This is an architecture that you can rip out that program and throw a new one in, right? The whole point is not that we're thinking about how we're supposed to get this done, but what do we need? And that we should think about this like car parts. You should be able to take one out and put another one in that serves what your data actually needs, alongside and married to what is the actual essential business thing that we're trying to solve. And I don't mean that in a corporate way. I literally just mean, what's the goal? What are you trying to achieve, right? It doesn't have to be in the industry. It could be a personal project, right? But thinking about the big picture, make sure that you don't lose the forest for the trees. And then let's talk about results, right? Like, you know, is this half worth what I'm suggesting? So I did this 3 times under 3 different circumstances. One of them was, this is not like a thing where I'm trying to promote. This is just strictly like, it was good enough. We got it published. We tried it out. We did it with ESA animals when, I don't know if everyone remembers, but when airlines were producing new laws and people were coming out with video photography and videos of like peacocks on an airplane, or that people had like alligators as pets. So it was just a really interesting time to kind of figure out how like the presumptions of an airport has presumptions on spaces and rules and what's allowed to be and not to be there. And we really wanted to understand the nuances of like, what are some presumptions? What are arguments people are making? What's the way that this space defines the way that we think about what should take place, both literally and metaphorically. The next one we did was just for the data size. And this was on a 2011 or 2012 MacBook, which had no firepower to it anymore. And we ran 1.3 gigabytes, which is nothing today, and you can easily overcome those numbers. But during way back when, that was actually a little bit of something where the MacBook struggled, and this whole analysis would take at least 20 minutes minimum. So we ran this, and we got some interesting results about what people were talking about in the Bitcoin world when it was really big, and when Elon Musk went on SNL and Dogecoin, and like you'd see some really interesting conversations pop up about what people were trying to do. And then the big problem was, how do you filter out the robots and the bots? Because they were just, you know, like, buy this, buy this, buy this, buy this. But we wanted to just understand, like, what were people thinking about Bitcoin online when most people didn't understand what this technology was about outside of sales. And then the last one was COVID-19, and this was a time analysis. What that means is we didn't just do one data set. We actually took snapshots over Trump's previous presidency and talking about COVID to see what people's reactions were over time. And with a little bit more analysis, you could actually map it to the news stories. It was really interesting that you could see the development over time on this analysis by digging in and kind of seeing what was going on. So it's not just like a marketing thing that I just showed you where you're trying to get a product, but there's different ways that you can interpret this, and allows you to really think about what is the goal, right? So I gave you a very academic version, right? A more public version, and then a temporal version. So you can run this a number of ways. Now this analysis, right, doesn't, you can't really mine Twitter as much anymore, but the techniques, the way to think about it, the what, right, that's the key. It's not how these things work, right? As you get into your developer experience and as you jump into these models, you're going to want to understand how it works so that when things go wrong, you know how to tinker or move it or rework it or clean it or this or that. But the real thing is, what am I trying to solve? What are the questions being asked? How do I turn those into techniques that I can help answer those questions? And maybe if there's an order to them, how do I place it in order such that I get the results that maybe I can't say, hey, you should use this, but I can say, these are the insights I found. How do we action on it? Who do I need to speak to? Who do I need to work with? And then suddenly it's a crazy model. Things go in, things come out. I don't know. We just have to trust it, right? But now you're in the loop. So David, I promised you I'd end a little bit early so we could talk and have questions, and that's what I promised. So thank you everyone for listening. I hope you found it enjoyable. This stuff isn't scary. It just requires a little bit of knowing what to look for and knowing what questions to ask. If anyone ever has any questions, you can always feel free to ping me or whatever. I'm on the Slack. But yeah, thank you, everyone. Feel free to ask any questions you want. Don't be shy. Now, see, David, now they're all ready to just go start doing AI, and that's it. You didn't even.
Yeah, that's fair. Yeah, everybody wants to hop
so
off the call.
intuitive. I'm done.
Yeah, that's fair. Also, this is recorded, as you could probably tell. So we'll have this for distro later. So no worries there if you want to review it. But yeah, Ofir is on the Slack, so he said you can message him. If you have questions, gripes, complaints about his presentation or any errors that you found.
It's always good. Makes you more human, I guess, right? Like,
Yeah, absolutely.
Whoops.
Absolutely.
And the conversations don't necessarily have to be around this. It can be around just like, what is it like breaking into the field? What are some resources? Like, what kinds of machine learning are there? Like, do I need to focus on this? Is this going to be the thing that takes my job, right? Like ask any of those questions. Those are all viable, real questions and scary ones that speak to different levels of anxiety and experience. Or type in the chat or don't. Perfectly fine.
Do you think you could answer all those questions in that order?
If you remind me of them, I sure can.
Now, I was wondering if you would, in terms of the threat of AI to the job market, if you have any thoughts on that.
Yeah, so I think that so there's two things. I think generative AI can be very harmful towards programmers, but not in the way you're thinking. From my understanding and what I've experienced and what I've really worked through with folks is the goal of what you're doing is not just solving business problems or coding problems. It's about visualizing in your head what's happening. And as you use more Gen AI stuff to help push your code, your trade-off is speed for intuition. And so if you can't visualize it, you should not be using it, right? It's very, very simple. If you know the operation and it's like that and you've done it 1,000 times, but you're like, I don't want to write this, cool, it's fine. You've understood enough. But if you don't know how to visualize a for loop and you're asking it to write you one, I promise you it's only hindering you. So focusing on making sure that you have the abstraction or the visualization, and you're able to render it the concepts imaginable in your head is the key, and that's what I focus on. So I think, yes, it is hurting you and it is hurting the job market, just not in the way that you might think. Now, where are companies trying to go? They're trying to make things more accessible. So what I've seen is that companies are trying to package these in little compact forms that you don't need to run any of the most stuff. It'll try to take care of maybe 80% for you. But what I just said constantly applies is just because it pumped out something, how do you know it's good? How do you judge that criteria? Even if a business analyst thinks they're now ready to do machine learning and run this algorithm because they can click some stuff, if they don't know the outputs, it's worthless and junk. So just because it's accessible doesn't mean it's usable, right? And that's what I think is the weird thing is we talk about accessibility in terms of use. This is the other way. It is just because it's accessible does not mean it's usable. So everything I just said still applies. They're trying to package it to make it more accessible to wider markets so that you can have different people in different working positions use them. But if you don't know the basics, it's not worth anything. Just like if someone doesn't know how to program and they're using ChatGPT to do like an API request, I can promise you, maybe they get it right. Maybe it works. But 2 years from now, I can promise you they're going to be hiring someone for that position because they have no idea how to fix it, right? Maintainability, sustainability, right? Those things are really important. And as much as you might produce these vibe code nonsense, you're going to eventually need to hire an engineer to go fix that because now your business is stuck on top of that. So now you have to fix what's on top with what's on bottom, and that's double the work. So I'm not really all that worried. Sometimes it's a really great thing. Sometimes it makes your life a lot easier, helps you explain stuff. There's plenty of benefits. But if you can't visualize it in your head and you're seeing companies just randomly use it because they think they should, and they're stuck with tech debt, and then you're going to have a job fixing that horrible code, and I can promise you'll want to gouge your eyes out. I can promise you. you can message me and email me when that happens.
Excellent. Thank you for that.
What was the next question?
I have no clue. I have no
See,
idea.
that's what I'm saying. I can't remember either. Concerns. Yeah, very scary. Very, very scary. Yes. Basically, a lot of what's coming out now are they're trying to figure out. So, Jennifer, is it okay if I just address you like directly? So for everyone's thumbs up, familiar with APIs. We feel good with APIs if I talk in that language, right? It's just a program that speaks to another program over the internet to get information. Oh, wow, there's a lot of thumbs up. Okay, great. Now it's going to search some things. Now it has your personal data. That thing's been hacked. So they're trying to make it, when I say they, the overlords that be the Googles, the Metas, the this, the that, they're all trying to figure out how to have your program interact with over a network, not just to get this piece of information through an API, but now expand it by searching Google, right? Like doing things that we don't typically do. That's what they're trying to do. And security is the biggest thing, because the moment you express that out of your defined network into the open is the moment it's a security risk. So personal information can accidentally go there, right? You use a GPT or a Gemini, it's retraining on those unless you're using the business version. And even still, that means that you're a security risk to your company. Like, these things are very scary if you are not being vigilant about two things, two good keywords: data security and data governance, right? Who are the blockers? How is the organization organized? Who has control over what? And what are the security things built into place to stop that from happening? This is huge security risks, just as big as like when they expressed SQL databases to JavaScript and there's something called SQL injections, right? It's that level of, I can get your data pretty quick. Now they're doing a really good job about keeping it secure. Don't get me wrong, right? Like every day they're testing, they're pumping out new things, but what's the trade-off, right? Like, what are you trying to solve that's really that important that you need to expose information that might be sensitive, right? Or maybe you need techniques like camouflaging your data so that you send it out and that the LLM can't read it because it's been scrambled. But maybe someone can break that, right? Maybe someone figures out how to reverse engineer that. I don't know. Again, the more shit you put out there, the more stuff you have, the more you think solving technology problems with other technologies and infrastructures is going to help you, is the moment you have security risks that pile up. So just solve the essential problem. I promise you 9 times out of 10, you don't need this. You don't need an agent speaking to another agent across the network and doing this and that and here and there. Like, do it for fun. Don't expose any information. Keep your stuff private. Keep your stuff secure. That stuff is going to be very important moving forward. I know we have a hard stop, but if anyone has any other questions, I'm happy to hang out for a couple more minutes. If not, have a beautiful night. Thank you so much for participating, and I look forward to seeing all of your success.
Yeah, really appreciate it. Again, Ofir is on Slack, so definitely message him if you have extra questions or anything like that. But yeah, appreciate you stopping in.
Thanks for having me, everyone.